Geometry lesson 2-6B, continuing more and more discussions with proofs and theorems. A little bit of information to add to your already growing repertoire of theorems. Congruent supplements theorem. Now congruent means exactly the same size, exactly the same shape. Supplements is any time two things add together to equal 180 degrees. So if we know that the measure of angle 1 and the measure of angle 2 equals 180 degrees, which makes them supplements, supplementary to each other, and we know that the measure of angle 2 and the measure of angle 3 equals 180 degrees, again, supplementary, the thing that's in common is angle 2. So let's just imagine that the angle 2 is 110 degrees. That means this has to be 70. If angle 2 is 110, it's still 110, which means this also has to be 70. Which would make the measures of angles 1 and 3 congruent to each other. They would both have to be 70. In a way, it's very similar to transitive, but it's not that they're congruent. We're not saying angles 1 and 2 are congruent, we're now saying that they're supplementary. And this value cannot change, so that forces these two to be the same. Congruent supplements theorem. We have the congruent complements theorem, which is very similar. You have two angles that add together to make 90 degrees. Another two angles that make 90 degrees, the thing they have in common is this angle 2 and this angle 2 have to be exactly the same. You can't switch angle 2's degrees from one to the other. So let's say angle 2 is 60. That would force angle 1 to be 30. If it's still 60, that means that angle 3 is also going to be 30, which forces angles 1 and angles 3 to be identical to each other. So congruent supplements theorem and the congruent complements theorem. And we have our linear pair postulate. We should recognize that this is a linear pair because together the two angles form 180 degrees. If two angles form a linear pair, then they are also going to be supplementary. Definition of supplementary, two angles add together to make 180 degrees. A linear pair, two angles add together to make 180 degrees. So all linear pairs are also supplementary. Okay, another example dealing with proofs. So here is a bunch of given information. The measure of angle 1 is 24 degrees. The measure of angle 3 is 24 degrees. So the fact that you know these two measures are the same, the measure of angle 1 and 3 are also going to be congruent. So we know that. Angles 1 and angles 2 are complementary. Angles 3 and angles 4 are complementary. Now if 1 and 2 are complementary, and you know that 1 and 3 are the same, you start to kind of use some of those complementary congruent supplements and congruent complementary theorems. We're proving that 2 is the same as 4 given this diagram. So let's look what we have, try to add some information. We know that angles 1 is 24 degrees. We also know that angle 3 is 24 degrees. We know that 1 and 2 are complementary, which means they form a 90-degree angle. And we know that 3 and 4 also form a 90-degree angle. We are trying to prove that this angle and this angle are exactly the same. Congruent. So our statements and our reasons. First of all, the given information. We know that 1 is 24 and 3 is 24, so that's given. If we wanted to remove the measures and we wanted to change this to congruent inside, we'd have to use something. I'm adding in some more given information. Angles 1 and angles 2, 3 and 4 are complementary, which means they form the 90 degrees. So that's all given info. From there, we can determine that the measure of angle 1 is the same as measure of angle 3. Measure of angle 1 is 24 and the measure of angle 3 is 24. So what do they have in common? The 24 is saying that the measure of angle 1 is the same as the measure of angle 3. So that's the transitive. From the transitive, notice now it's got a measurement, but it doesn't anymore. And instead of being equal, it's now saying congruent. That's the definition of congruent angles. These two looks. Be very clear about this. If it has the measure and equal, and you want it to get rid of the measure and say congruent, that's definition of congruent angles. If you have the fact that you have angles that are congruent, but you want to say the measurements of them are equal to each other, that's definition of congruent angles. And finally, because we know that angles 1 is congruent to angles 3, that would mean that angles 2 are congruent to angle 4 because of the congruent complements theorem. It's based off of this right here. We know that 1 was the same as 2, and 2 is the same as 3, therefore 1 would be the same as 3. The only difference is the numbers they're using. So if angle 1 is the same as angle 3, which is what that's saying, they can't be any different. That's going to force these two to be the same. because of the congruent complements theorem. Alright, now this one's a little different. You've got this diagram. We're just going to explain it. We're not going to necessarily do it as a two-column proof. So the measure of angle 1 is 60 degrees. That means it's 60 degrees right here. We also know that BFD, B to F to D, is a right angle. So that's a right angle there. And we want to show that angle 4 is 30. We want to prove that this is 30 degrees. So one thing we could do is we could say, well, we know that if you take angle 1 and you add it to BFD, you're going to get 150 degrees. And I know that because if that's what it is, that's 60, and the fact that this is a right angle means that's 90. So by substitution, 60 plus 90 makes 150. So we're just taking the given information and we would substitute it. So we know that from here to here is 150 degrees. We figured that out right here, which is the same idea as the measure of angle 1 plus the measure of angle BFD equals angle AFD, A to F to D. And that's just angle addition postulate. If you add two angles together, it'll make the third angle. Now we know that AFD and angle 4, because angle 4 is all that's left, we know that this creates 180 degrees. So if that's 180 degrees together, then we know that 150, which is AFD, these two are the same. 150 plus angle 4 makes 180. If you subtract 150 by the subtraction property of equality, you would get angle 4 is 30 degrees. So logically, we can explain the flow. This is more of what we would call similar to a paragraph proof rather than a two-column reasons, statements and reasons, two-column proof. One more theorem is the vertical angles theorem. We've talked about vertical angles. We know with vertical angles that these two will be the same and these two will be the same by vertical angles. The vertical angles will say that if they are truly vertical angles, they'll be congruent. So 1 is congruent with 3, 2 is congruent with 4. And one more example of a proof. We'll go back to two-column proof. Given that angles 1 and 2 are a linear pair, which means together they're 180 degrees, right? A linear pair. And 2 and 3 are also a linear pair, so 180 degrees. If you've got 1 and 2, and 2 and 3, 2 does not get to change value. Whatever 2 is stays the same, so that would tell us that angles 1 and 3 are going to be identical to each other because of the congruent supplements theorem. So we know that that might come into play in this problem. Here's the diagram. We're trying to prove that angle 1 is congruent to angle 3. So we know that 1 and 2 are a linear pair. That means that this right here is 180 degrees. We know that 2 and 3 are a linear pair. And if you'll notice, that angle 2 does not get to change values for either one of them. That means that these two have to be congruent to each other, 1 and 3, which is what we're going to prove. So our statements and our reasons. First of all the given information about the two sets of linear pairs. That's all we had that was given information. From that given information, we know that 1 and 2 are supplementary. We know that because they're a linear pair. We also know that 2 and 3 are supplementary because they are a linear pair, which means they're going to form 180 degrees. From there, notice 1 and 2 are supplementary, 2 and 3 are supplementary. It's very similar to going, oh, take those out. We know 1 and 3 are congruent to each other because of the congruent supplementary theorem. This theorem right here, congruent supplements theorem. And we have now succeeded in proving what we were after.